giving people sight through a bionic eye. Leading the race to create the world's first quantum computer in silicon. Setting world records year after year for efficiency in solar energy cells. These are just some of the research projects that make UNSW Engineering the leading engineering faculty in Australia and one of the best known engineering faculties internationally. A top-ranking faculty for research quality and student experience. One of the top 40 engineering faculties worldwide, 10,000 students. Close links with industry partners, including some of the world's top-performing companies.
The Faculty of Engineering at the University of New South Wales was founded in 1949 when it was part of Sydney Technical College. Today we're Australia's top-rated engineering faculty. We offer the widest range of degrees, we recruit the best students, and from that our students then are able to get the best jobs, the highest paid salaries, and really contribute to society at large.
The Faculty of Engineering covers a host of engineering disciplines including civil, mechanical, electrical and chemical engineering, as well as emerging fields like food, health, energy, digital services, computing and climate change. We are renowned for our engineering excellence throughout the world, with 2 of our schools, civil and chemical engineering, ranked in the top 15 in the world.
UNSW is leading the race to build a functioning quantum computer that one day will be used for highly complex calculations in such fields as medical research, data security and climate modelling.
The difference between a quantum computer and a conventional computer is that in a conventional computer, information is stored in a binary code of zeros and ones called bits. In a quantum computer, those bits are called quantum bits or qubits, which can be both a 0 and a 1 at the same time.
This is the Quantum Spin Control Laboratory, 1 floor below the nanofabrication facility, and it is in this laboratory that we have demonstrated for the first time in the world the complete operation of a single quantum bit based on a single atom in a silicon chip.
The Faculty of Engineering at UNSW is also developing compression standards to enable greater interaction with digital media.
The world is moving towards what we might call multi-view video or free viewpoint video, but more generally media which actually just represents a scene, right? Perhaps in intricate detail. You don't just sit back and watch it. You navigate within it, you interact with it, you move around in it. So it's that interaction with the content that we're really interested in. What we've been doing has been used in medical applications to record that content and also to bring that content to doctors around the world. In addition to that, we have a lot of companies who use our work in interactive media. One recent example is a surveillance company in the US. They produce equipment which is installed in various port facilities, and what it's able to do is to survey the entire port. All of this can be viewed remotely by various security personnel who couldn't possibly see the entire content simultaneously. So rather than having a lot of different TV screens or a lot of different cameras that they can look at, they interact with the media. What we're working on is essentially where the world is going.
Digital innovation at UNSW also includes work like using satellite imagery to improve disaster recovery and research to support the development of Australia's fledgling space program.
We're looking to develop Australian capability in space by looking at small, manageable sized satellite developments that could then be used to bootstrap an Australian space industry. And in terms of the future, we're looking at off-Earth mining as an exciting new area of research.
Digital media is also being used to save lives by taking the risk out of training mining workers.
This is our school's virtual reality theatre. It's an immersive theatre designed to be able to have groups in here interacting with a range of environments. So we've developed this and the whole field of virtual reality as part of our innovative teaching and learning research within the school. We started about 10 or 12 years ago and now have about 18 different modules we've developed for student education as well as industry training. The beauty of it is we can immerse people in environments which we can't otherwise easily get to, such as an underground mine, as you see here. We can expose them to potentially high hazard scenarios without obviously any safety risks. It's all about learning effectiveness, that immersive experience that students can get, that they learn so much more effectively than in a normal classroom environment.
Ask any international player in the world of solar energy who leads the way, and two names crop up: Professor Martin Green and Professor Stuart Wenham.
Our group at the university started making the best silicon solar cells in the world about 20 years ago, and ever since then we've been able to make solar cells that are higher in performance than anywhere else in the world.
There's international studies that have been done that have said what type of efficiencies will be achieved by the industry in the long term, and we believe we can get well above those sorts of efficiencies. In fact, an international panel of experts in the last 12 months have predicted that 20% efficiency would pretty much be the limit, and yet within the last 12 months we've already hit that particular figure with some of our industry partners and achieved world records at the same time.
Solar energy is now just one strand of research strategy that addresses renewable and conventional energy. Much of this work is housed in the purpose-built Tyree Energy Technologies building, a Green Star energy-efficient space that acts as a living laboratory for researchers across many different faculties. Water quality and access is one of the defining problems of the 21st century. Water research at UNSW brings together the university's civil and environmental engineers and scientists to collaborate on research addressing floods, drought, groundwater, desalination, water quality and salinity. One of our more high-profile international projects examines beach erosion, how rising sea levels and changing wave patterns will affect our coastlines against the background of climate change.
The monitoring and modelling work that we're doing, they're both at the cutting edge. We now use cameras to both measure the width of the beach, and by some clever manipulation of those pictures, we can even actually calculate the volume of sand on the beach. And we do that every hour. So we now have very sophisticated ways of measuring, quantifying sand coming and going.
My specific part of this project is looking at developing numerical models that we can use to actually reproduce what we're seeing out here on a day-to-day basis. And then once we're confident in that, we then use those models to be able to predict where the beach may be in 10, 15 or 50 years.
Our skills in developing sustainable solutions extends to conventional industries. UNSW is working hard with the manufacturing industry to minimise its carbon footprint and better use the raw materials that go into products.
In order to achieve sustainability in manufacturing, what we need is a life cycle thinking. Some of our end-of-life products are actually highly toxic. For instance, when we look at the LCD screen, there's a mercury in it. So it's actually very dangerous from the human health perspective to disassemble that manually. So we need to come up with a robotic solution. What we are doing is try to introduce cognitive ability to the robots. When they see a brand new product they've never seen before, they actually, let's say, try to disassemble it, learn from that, and the next time when they see the model, they understand it's the same model, and then they know what to do with it.
The future of Australian manufacturing lies with new technologies such as nano and bio-manufacturing. UNSW has Australia's only nanotechnology machining centre.
The positioning accuracy of this machine is 1 nanometer in all the 5 axes. So you can position your cutting tool with 1 nanometer resolution so that you can operate and then you can manufacture components with very high accuracy.
We don't automatically think of engineers when we consider health solutions. But at UNSW Engineering, our world-first innovations will radically alter people's quality of life. Like this bionic eye that will restore partial sight to those with macular degeneration.
This is our prototype bionic eye. It consists of 2 cameras that capture an image. They're mounted on these glasses. The image is sent to our processing unit and converts it into a series of stimulation commands that are sent to a transmitter that is mounted here behind the ear.
Then the signals come to an implant which is placed on top of the eye with a small incision made in the side of the eye so that we can slide an electrode array around to the back of the retina. It receives these instructions from Nigel's system, and that causes a signal to go down the optic nerve and be interpreted as vision by the patient.
Imagine, too, a drug delivery system that sends medication to a specific part of the body and drops particles so small that they can leave no side effects.
We are basically on a mission to help cancer research. So what we would like to do is to deliver drugs more effectively, increase the solubility, but also maybe to help aiming the drug at a certain site, at a certain tumor, for example.
Another project has the potential to relieve the suffering of countless hip joint patients around the world.
At the moment, the hip joint lifetime span is mostly 15 years, then you have to replace it. And we try to make the joint which can never wear. You can install it over there forever for your whole life.
The smooth functioning of urban centres relies on well-planned infrastructure.
One thing in particular that we've developed that is a world first is ways of quantifying the system impact of information. If you're thinking of doing something operationally, like active traffic management, where you're trying to manage the second-to-second dynamics of a motorway, we actually go a step further and quantify the effect across the system. So just because you're managing some particular segment of roadway, you may have an interaction halfway across your system. And traditionally that's something that agencies have not focused on.
The faculty is trying to solve some of the big problems in the world today. Things such as energy, water, health. The engineers we want to produce are inherently problem solvers. They're innovative and they're creative, but they're using this creative ability to solve real problems of global importance. And those are the sort of students that we're after today.